everyone. Welcome to a hands-on walkthrough of Cisco MDS switches, all managed through the Nexus Dashboard. If you are looking to simplify SAM management or boosting the performance and the visibility, you are in the right place. So let's start with the basics. So in this lab will give you direct access to key features like switch onboarding, configuration, troubleshooting, and managing the software images and the backups. Everything's streamlined through the Nexus dashboard, so you're not jumping between tools. Now, let's talk about the SAN Insights. It is where things get really smart. SAN Insight is built right into the dashboard and uses real-time telemetry to monitor your SAM fabric, and it helps you detect congestions, find the slow drain sources, and optimize the performance across the board. So the whole solution is built on a powerful three-layer architecture. First layer is the hardware, the Cisco MDS switches. As the foundation are the Cisco MDS 9000, right? Nice. Okay. Switches. So these are designed for high throughput and reliability, which has the 64 gig fiber channel line cards and dedicated network process unit MPUs. That means you can get real-time telemetry and advanced congestion control perfect for modern workloads like NVMe. over the over the fabric channel, over the FC. Okay, fabric channel. So plus you get detailed metrics like TX weight contours for deep troubleshooting and analytics. The second layer is the management, the Cisco Nexus Dashboard. This is your centralized control hub. The Nexus Dashboard brings everything together: configuration, monitoring, upgrades, and automation all in one place. And you can automate tasks like IVR zoning. We can have a zoning and device aliasing and policy deployment, which saves time and keeps your SAN consistent and efficient. Is the third layer. The third layer we're talking about is the SAM, SAM Insights. The SAM Insights is analytic engine for solutions, like it puts in over 80 real-time metrics to give you the full visibility into the fabric performance. And you will see the indicators like host read latency, exchange completion time, and device access latency. It doesn't just monitor, it acts. With features like dynamic ingress rate limit, like DIRL, dynamic ingress rate limiting. So it's automatically throttle traffic from aggressive hosts to prevent congestions. So it also checks the path redundancy to help you avoid the single point failure and keep your SAN highly available. So that's it. Cisco MDS switches plus Nexus dashboard is a smarter, faster, and more reliant SAN. Section is we'll have to take a look at MDS configuration via the CLI, which is designated to verify the configuration, and we will show the operational status of a fabric channel. interface, and it would be checking the interface states, ISL connections, the fabric topology, the device registration, and the MPIV features. So this is basically we're checking to ensure the proper connectivity between switches, storage array, and connected host, right? So let's open a party and we're going to log on to the edge switch, and we're going to show interface brief, and log on to the core, show interface brief. On the core switch, FC1/1 should have the status of up and the mode of F, showing they are connected to the pure array, storage array. On the edge switch, interface 1/3 to 1/6 should have status for trunking and mode of TE. Is confirming they are serve as interswitch link ISL to the edge switch. Go to core switch, and I will show command topology. This command shows topology of the fabric, including 4 ISLs to the edge. Then we will show FCNS database that it confirms the devices are registered with the fabric in name server. It ensures they can discover and communicate with each other. Without registration, device won't be visible in the SAN, leading to connectivity or zoning issue. Same thing we can here show topology. We have ISLs and show FCNS database. And here you can see the same thing on edge. Show FCNS database local. We'll show the host connected to the edge switch here. Same thing, if we go to the core, show FCNS database local. The import ID virtualization MPIV features allow multiple FCIDs to be designated to a single endpoint. So it enables multiple applications to use separate FCIDs. It allows the traffic access control, zoning, and port level security to be enforced independently. The MPID, import ID virtualization, is enabled by default, but this verification is recommended. So go to core, show features, and we can locate is MPIV. It's enabled. In the edge, show features, MPIV is enabled. So everything we checked will provide a quick way to validate the SAN fabric health, ensuring the reliable connectivity between the switches and the storage host. It helps to identify the misconfiguration early, also support a fast troubleshooting, right? Now, for the next, we'll transition to using Cisco Nexus Dashboard to manage the SAM fabric through the graphical interface. So we'll begin by adding the seed MDS switches to automatically discover all interconnected switches in Fabric. Once discover is complete, we will check the Fabric topology and explore switches details. We can navigate through the key dashboard tabs and go ahead to configure the port channel, zone sets, and zoning. Okay, so we can go to admin and system setting. Let's select feature management and we'll check the box next to SAN Web Management Manager and the SAN Insights feature, and we'll click apply. Status column reports like status for both features. We'll move forward to the next step. We wanted to see the status column change value as it activates the feature right now, and after a few minutes, the status will change to started. Let's go to manage and go fabric. Let's add a fabric name, say MDS Fabric. That's the fabric name, and we're going to specify a seed switch. It is the edge switch, and we'll provide a username, password. Click add. After successfully adding the fabric, we're going to click OK. And my new fabric, MDS Fabric, shows up. Double click on Fabric, and it will direct me to the Fabric Overview dashboard. This is my central hub for monitoring the health, the status, and the performance of the entire fabric at a glance. So initial view defaults to summary, which provides a high-level snapshot of fabric's the current status. Here's the fabric information. It provides the essential identity and the status information, including the fabric name and the fabric state and its overall health. In here, the health is marked as healthy, showing like it's good. To event analytics, this is my primary indicator for any active issues. It categorizes and counts the faults and separating them into alarms. It has active and service impacting issues. The events is about informational and historical logs. If you see a red bar, quickly will draw your attention to the critical issues. And you could see the links. This panel is visualizes status of physical connections within the fabric. It all share a simple count of the links that are in OK state versus those that may have issues, right? Here, the fabric overview contains several other tabs for the deep dive into the specific components. So we have switches. Here you can see a detailed list of all switches in the fabric, including their health, their model, their software version. Go to modules. Here we can see status for all modules installed in the switches, and interfaces will get a comprehensive view of all ports and their operational state. vSANs. Here we see the configuration of all virtual SANs within the fabric. Next, we'll create a port channel utilizing the ISLs, inter-switch links, that connect our edge switch to our core switch. So to begin creating our port channel, we're going to navigate to the existing physical links that I will aggregate. So on the navigation panel, let's go to manage and find inventory from the option. Here we can go to links tab, and then we're going to select ISLs to see all active inter-switch links. I should see 4 distinct entries showing the physical interface connecting to edge and the core switch. Then we're going to launch the port channel creation wizard. From the action menu, we'll have to create port channel, and we'll give a fabric, and my switch pair shows up, core and edge, 4 SSL. Go next. Okay. 4 interfaces, and we can select them into the final stage. We're going to see the default configuration. We can note that the channel ID is set to 1, and the trunk mode is auto. Trunk mode should be auto. Speed is auto. Okay. Go ahead, and we can click new port channel. It will take some time, normally 15 seconds, and refresh my page. I will now see that 4 individual ISL entries have been replaced by a single entry representing the newly created port channel. Name is core port channel 1, edge port channel 1. Okay? The speed is 64 GB per second. Next, we'll take care is creation of a zone set and creation configuring the zoning. So zoning enables us to set up access control between storage device and user groups. If we have an administrator privilege in the fabric, I can create zones to increase network security and to prevent data loss or corruption. So zoning is enforced by examining the source and destination ID field. What does mean? So let's just create one to show you. And we'll have to create a zone set. The zone set is a collection of zones and are used to define a communication path between the device. So it's a way to group zones together and activate them as a single unit within a vSAN or virtual SAN. Only one zone set can be active at a time within a vSAN, and it determines which device can communicate with each other. Go to manage and zoning to make sure here in the fabric I pick vSAN 001 and switches edge. In the action, we can create zone set. give it name zone set -1, and on the new page here, we want to edit this. Create new zone. Double click the zone set. Say that's zone 1. In the right menu, we can see the member. We're going to add members. We're going to find future, the F Fabric channel 1/1. So I mean, I'm targeting this one and this one. Add a member. Now, make sure you select the zone 1, and we're gonna click add to zone set. The value in zone set is set to true, showing like zone 1 has been added to our zone set 1. Now we're gonna click activate zone set 1. It failed that time because no member. Let's add. Confirm that. It's gonna work. Okay. Close this for now. Here's my Fabric status, but I'm going to zones. I'm going to show you the topology. I think we should have a small icon next to the zone. Here, this is what I'm talking about. Show topology. Here you go. Make it better looking here. This is the topology for the zoning. It's showing like what I show you right here. Now let's verify the zoning configuration in the CLI. In the core switch, we'll show zone status vSAN 1 and show zone set vSAN 1. Zone set active vSAN 1. Then show running config zone vSAN 1. We can see the zone set and zone we created in the UI in dashboard. Here's a PWWN member. We can click this compute node. You can see the PWWN number. This compute number. and compare them here. Okay. Okay, go. It's initiators WN FCID. After enabling the SAN Insight feature in the dashboards, the Fabric initial configuration, the next step is to configure the performance monitoring and the SAN Insights for the Fabric. Performance monitoring is a real-time performance status, which is a useful tool in dynamic troubleshooting and fault isolation within the Fabric. It will gather data on the parts of a fabric in the user configurable intervals and displays some results in the dashboards and the device manager. Let's go to the manage, go to fabric. Let's find this fabric. Click action, config performance. This global setting, we want to enable SAN, sensor discovery. We enable temperature for SAN switches. We're going to select the performance collection for ISN, MPV links, host, and the storage. And so we're going to click apply. Confirm. All right, let's select this fabric again. We're going to configure performance. The SAN Insight, here's the wizard. Click apply. Confirm this. Select this fabric and we'll configure SAN Insights. So this wizard, click next. The subscription for both core and edge switch, we're going to select SCSI and NVMe. SCSI and NVMe. In install query, the edge is connecting host. So I choose host. The core is storage. And let's select two switch together. Next. Bandwidth module. Next. Let's choose the host. On the edge and core, this storage. And next. Let's commit. We can close now. After enabling performance monitor and SAN insights in the fabric, the next step is to configure the most aggressive monitoring policy to showcase the congestion and analytics, the scenarios. We're going to apply most aggressive all port template. So go to manage and port monitoring. We want to select the port monitoring policy, most aggressive all port, most aggressive all ports. In this logical type, we're going to select all and want to push to switch. In this pop-up window, underscore scope, I'm going to expand this data center. We'll select vSAN. yeah, vSAN, just to make sure both core and edge switches are automatically selected. Okay, and click push to the switch. I'm going to wait a few seconds until the confirmation window shows. Here, confirm. Click OK. We'll go to dashboards, and in the left, we'll pick Analyze, Event Analytics, Alarm Policies. Make sure the status equals not active. Let's select all of them. So the purpose we're going to activate them. The event analytics service will provide the core frameworks for monitoring and alerting within the SAM Fabric environment. Central to this service is alarm policies feature. So what I'm showing you, this feature acts as a management point for rules and govern automated alarm generation. So the key type of policy available for configuration is the SAN Insights Anomaly Policy. So these policies are designed to leverage detailed SAN Insight telemetry to create customized alarms that help identify issues within the fabric. So the alarm allows SAN Insight policy to be pre-provisioned with some not in active state by default. So these require manual activation. Once active, the policies monitor critical performance indicators just by evaluating telemetry data against administrator defined thresholds. So we configure a SAN anomaly. Policy involves defining match rules that compare telemetry data fields against specific values. So this enables the administrators to proactively detect and receive notifications for a range of conditions by activating policies here, such as read IO fail or white IO fail, that triggers alarms when a single IO operation fail, or providing immediate insights into critical path errors that may affect application vulnerability, right? Another one is read IO abort. So, and white IO abort. So it generates alarm when the IO operation is aborted, showing the potential the fabric or endpoint issue. The many offer lists, for example, the right IO size, read IO size, like it shows the flows with exceptional large IO sizes that may be expected for certain workloads or could indicate the anomalies requiring the investigation, right? So after all that, we want to activate these alarms. To thoroughly simulate and validate congestion analysis and SAN insight performance in Cisco MDS 9000 fabric, where the test fabric is generated between the initiator and the target device using my run script and the test script. This process is critical for just assessing the fabric behavior on the loads and will identify the bottlenecks and diagnose the slow drain issues with high precision, right? Let's click this run script, run with PowerShell. So this tool will start generate traffic testing between initiator and target. The test will run for 5 minutes, and we'll just leave this test window open. Go Manage Fabric. Double click Fabric. On the list of Fabric here, one click Congestion Analysis. This Congestion Analysis window will show the congestion data for selected fabric over the last 24 hours by default. Let's take a look at the SAN Insight. Go Analysis, SAN Insights. And monitor the traffic flow. Click Monitor Metrics. Choose between host enclosures, storage enclosures, and pair. Can pick a range. Okay. And now let's select the first initiator and target pair. Once we drill into it, so this tool takes us into a dedicated view where we can monitor this specific flow in detail. Here we can see all key SAN performance metrics. There's the IOPS, throughput, ETC is a exchange completion time and device access latency, DAL. This source WN, destination WN. SID is a source ID, FCID of the initiator, and this the DID, destination ID. Is the FCID of the target, like the storage array. IOPS measures how many IO operations are happening per second. And for performance tuning, the higher IPOS is fine if the latency ECT and DL remains low, right? Throughput is amount of data per second being transferred. The reads are large block operations. So higher throughput, few IOPS per MP. The writes are small block. There's a lower throughput, but still some IOPS. The EDC here is this average time to complete I/O end-to-end latency that's seen by the fabric. It's essentially end-to-end fabric and storage response latency. Let's scroll further down. This tells us exactly how devices are connected, with each element represented by the color that shows the health status, right? In this case, my path is green, meaning the SAN itself is healthy. We don't have a congestion at any ports at the host side or the server side, the storage side. So this virtual confirmation is perfectly aligned like what we've seen before. Scroll a little bit down here. Here we can see the average and baselines in different performance indicators. We can see the average and normal values for read and write ECT deviation over the last 1 hour period. You can see the IOs, DL, and many other critical metrics. Here's the right side. Here we can see the specific ports we selected earlier in the topology. For example, here, can pick here for the core. Now pick the edge, and this is showing the chart. So next I want to talk about is automation, the NX API on the Cisco MDS switch. Traditionally, administrators access the command line interface directly on the switch using a console or SSH session where effective. This method can be limiting for automation and remote management. The NX API enhances this experience by exposing the CLI programmatically over standard web protocol like HTTP and HTTPS. This means we can send CLI commands and receive the structured output remotely, no console or SSH required. Commands and their outputs are embedded in body of HTTP or HTTPS post request. The NX API supports multiple data formats, including the XML, JSON, and JSON RPC. So that makes it compatible with modern automation frameworks and REST-based tools. So this a key feature for learning and testing is the NX API developer sandbox. So this web-based interface is hosted directly on the switch. So this allows us to craft and send NX API requests and see formatted responses, all without needing external software. So this step we're going to walk you through how to configure the NX API service, and you use developer sandbox to interact with the switch, and this will enable powerful automation workflow and simplify remote management. So let's get to it. Getting to the core and enter global configuration mode, and we're going to say feature NX API, and we're going to enable web-based developer sandbox, just NX API sandbox, NX API HTTPS, port is a 443, and NX API HTTP port 8080, show NX API that was is running and it is sending on the correct port 8080 a 443. Signing into this switch on port A443 and click to enter the command. So show zone set. I'm trying show zone set. Activate vSAN1 and the request is here. Click post. Now the NX API developer sandbox window is web-based, and from it will translate NX OS CLI commands into the equivalent to VXML or JSON payloads and convert the NX API payloads into their CLI equivalent at least the response. And we could do is make a XML, JSON. The way my tool I just ran, and I can see the congestion happening. Now I'm back here to the congestion analysis. Apologize to you because my tool just ran, and I can see my testing results. The TB2B20 here, we can see shows the value of 98.9295. So each increment signifies that a switched port is to transmit the TX buffer to buffer credits dropped to 0. And this happens when connected to storage device with host credits, forcing the switch to pause transmission. So what it counts is high, and the metrics alone doesn't indicate the severity of congestion because it doesn't measure the duration of the stores. TX wait in seconds, the counter is showing a value of 0.008, 0.07 seconds. So this is total cumulative time the port has spent waiting for transmit credits. The value is calculated from a device counter that is increments every 2.5 microseconds, and a port is stored. A metric here provides a clear picture of congestion's impact than this TXB2B20, right? Here's the peak TX weight. So this shows 0.01%. It shows the higher is the percentage of congestion measured during any single polling interval throughput monitor periods. So this low percentage suggests that the congestion is occurring in short, intermittent bursts rather than as a sustained problem, right? Let's click this chart. I can see this traffic congestion. Okay, close that. Let's scroll down to this topology. Here's a congestion analysis to see the topology of selected fabric. The topology shows color-coded nodes that links corresponding to various network elements. So each of the elements you can hover over for more information here. Let's close that. I'll take you to analysis, Cisco Insights. Monitor metrics. You can see this red or orange. Go at T pairs. Which is in yellow, as I see. Go click the edge, and I want to see if the charge is showing. Yep, here you go. Is the edge, transmit and receive, core, transmit and receive. ETC, end-to-end latency, DAL, data storage device targets itself, the latency.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.